All right, welcome to the instructional video for Math 20-1 9.1, which is linear inequalities in two variables. You've solved inequalities before, like, maybe x, 2x plus 4 is greater than 3 or something like that. The key difference here is that we're going to talk about linear inequalities in two variables. So we have to talk about that Cartesian plane, the xy axis, and we are going to talk about straight lines in 9.1. They say, and this is from your textbook, that they can be in one of the following four forms, but it's just as true that we could put them into the y equals mx plus b form. So they don't have to be in general form to solve this. What is really important, though, is that when you solve an inequality, you get an interval of solutions. When you solve a graphical inequality, you get a region of solutions. So there's going to be an area that solves this. And they call that the solution region. And the solution region would identify, and they show right here that the peach is the solution region, which means any of the points that I'm dotting here are solutions to this inequality. And I'm going to show you that in the notes as we do examples. I think the most important thing to remember about this is that when we graph an inequality, there is not one answer. There's a group of answers. In the case of, two variable inequalities, it's a region, an area. In the case of a single variable inequality, it's an interval. So some section of the number line that would solve that. That's a really important consideration, that when we solve this, we are going to look at, kind of shading to indicate just where those points could be, because we are never going to be able to list all the points. I mean, I dotted this 20 times. I would never want to list those 20 points. Instead, we would draw the graph and show that everywhere in this peach shaded area, that would be a solution. Now, there's a couple other little housekeeping things, that if the inequality is less than or equal to or greater than or equal to, we use a solid line. And if the inequality is just less than or greater than, we use a dash line. And the kind of analogy that you've dealt with, and I want to draw this, that if I looked at the difference between x is greater than 4 and x is greater than or equal to 4 on a number line, if x is greater than 4, there's an open dot at 4, and then we shade everything to the right of it. If x is greater than or equal to 4, there's a solid dot at 4, and then we shade everything to the right of it. That's the same concept when we use a dotted line or a solid line. A solid line indicates that it can be points on that line. Those are okay. A dash line indicates that it can be points next to or near that line, but not the points themselves. And we'll fully discover this as we work through the examples in 9.1. Your calculator is going to be a very, very useful tool in this section.